Hey everyone, thanks for checking out a recent project I created called fakesmtp-web. In this video, I'm just going to show you how to set it up, get it all running, the motivation behind it, and other bits and pieces. So basically this project builds upon fakesmtp, which is a fake email server written in Java. It also has a Java Swing user interface here. So what I wanted to do was I wanted to run fakesmtp in a Docker container and access the emails through a web user interface, as well as have a REST API. So as it turns out, a couple of other people wanted these features as well. There's a feature request here, so they wanted to use it in Docker as well, connect to it through a web UI, and also have a REST API to connect to. So that's why I created fakesmtp-web, which implements all these requirements. So yeah, it provides a REST API. All the new emails are published to a server-sent event stream for live updates, and the web UI is written in Elm. So it's really easy to get started. I recommend that you have Docker Compose installed, as it's literally just one command to get it all up and running. Also have the default image available on Docker Hub for convenience, so you can just pull that down to get started. But yeah, to get started, we'll just get stuck into a demo, and I'll explain things how we go as we go. But literally, all you need to do is just copy and paste the Docker Compose config and head to a terminal. The Docker Compose config can go anywhere really, but I'm just going to create a new directory to put it in. And then I'm just going to create an empty Docker Compose file and paste the config into there. So if you don't have Docker Compose, I've got instructions on my GitHub on how to start each container individually. But yeah, with Docker Compose it's really easy to get started, so I definitely recommend doing that. But you'll notice that there's two services here. There's fakesmtp, which is the Dockerized version of fakesmtp. So big thanks to this person here who has already Dockerized it all. So that made life a lot easier. So we've utilized that in this project, and that needs to be started first. And then once that is started, we start out the web service. So we can. I've already got the Docker images downloaded, so my startup is going to be really fast. So the first time you run it, you'll have to download the Dockerized fakesmtp, which is 333 meg, and you also have to download the web service, which is 142 meg. But yeah, to get started, you just need to run Docker Compose up. You can also put it into touch mode so you don't clog up your terminal. So you see that fakesmtp starts first, and then the web service starts second. It takes about a minute for the web service to start while the server boots up, gets ready. But once it's all ready, we can navigate to our web UI. We can see here, I've just got the instructions that you need to go to this address. This is what the default Docker image has in there, so this has to be used. You can't do any Docker port mappings because the client-side UI has all the API endpoints fixed at this. So to change this, I've got a section here in API import settings section, and you can do a custom build which modifies it. But for the most case, I'm hoping that this is fine for everyone. So that should be all up and running. If we connect to our user interface here, this is what we get. I'll just zoom out a bit so we can see it. So obviously there's no emails in there, but just to give you an idea of how it works, what happened is the fake email server will write emails into this directory here, which is on our host machine down here. So that's where all the emails will be getting written to by the email server. And the web service, every 10 seconds, it will scan this directory and see if there's any new emails. If there's any new emails, what will happen is they will get published to the REST API, and it will also get published to the web user interface through the server-sent event stream. And yeah, it's really easy in Docker to do this because you can basically just mount a directory on the host machine to the directory inside the container, and we're basically just connecting these two Docker containers to share the data in this directory. And as an implementation detail, I actually used Spring integration for the web service, which does the polling of this directory, passes the email, sends it into a message queue, and then saves the email to a in-memory database to be exposed to the REST API, and then it also dispatches an email through the server-sent event stream for the web UI to read. So once that's all done, we can start looking at emails. There's an API section here that shows you all the REST API endpoints, but just to start, I'm going to connect to the server-sent event stream here, just to show you that the emails are trickling through. The web UI is already connected to it, which is up here. That just means it's connected to the server-sent event stream, listening for emails. So I'm just going to go ahead and start copying emails across. At the end, I'll show you a live example using a proper email service in action. Desktop sample emails A1. So this will get polled every 10 seconds. So it will come through here on the left when the directory is scanned, as we can see there. I'll just put a few more through here. A5 CC and one last one, so we get 5. So they're all coming through here. They're also coming through this event stream here as well. We'll just wait for the last email to come through, and then we'll have a look at the details. So you can see some metadata here, like how many attachments there are, how many people are CC'd into it. You can also look at the detail view here. Depending on what fields are available is what is shown. So not every email has a CC. Not every email has attachments, for example. And yeah, most of the email information here is quite handy. So you can see the media type of the attachment and the body, as well as the character encoding type. Toggle unread status, and you can also delete emails. You can set them all to read or unread, which is quite useful in debugging. And we'll have a look at the API, the REST API. So on my GitHub here, I've got all the endpoints published, and it just shows you the structure of what JSON response you get back for an email. Most of these fields are based on what's available in the Java MIME message type. So there's quite a lot of detail there. So yeah, you can get all the emails, get single emails. You can also update any field in the email through a patch. So if you wanted to mark the red field, you can do that. Red's true. You can also do deletes, and that has a 204 no content, which means it was successful. And that is about it for the REST API stuff. Like I said, documentation's all there outlining what's available. And just to finish up, I've got a real world example here to show. I've got another application that is a Spring Boot user registration service. So basically, you sign up to a website, you get sent an email, and you've got to click the link to register. Just showing you how you can use this application to have a look at that process if you wanted to test an email service that was working, and but the HTML email was what you expected. So I started that up in another window now. It should be up and running. So this is the registration form. I'm just going to do a fake user here. And that email is going to be sent by the Java Mail API using Spring Boot. That should come through in a minute, and then we'll be able to have a look at the details. So the email that gets sent, as we've received it now, is a HTML template using Timeleaf, and that gets rendered down here. There's also an activate leak here, so we can test that that's working. And yeah, your account is now active, and we can log in. So yeah, hopefully that just gives you a little bit of an idea of what you can do. That's all done, so you can delete them all and start debugging again. But yeah, any more information or any issues, just have a look at my GitHub and let me know. But yeah, thanks for watching.